Video time. Let's talk about marine heat waves. You could call them ocean heat waves. I've mentioned marine heat waves a little bit on this channel recently. Didn't really take much time to explain them. I showed how they're reflected on the maps and what the maps tell us about marine heat waves, but time to go into that now, because global heating is now reflecting itself in marine heat waves, and marine heat waves can do a lot of mischief, to put it mildly. So mischief, what are we talking about? We're talking about, we just had torrential rains in Hawaii caused by marine heat wave and global heating, and we just had pretty much back-to-back severe weather outbreaks in the central and eastern U.S., back-to-back, maybe separated by a few days, also caused by both marine heat waves and global heating. And there is a massive, very consequential heat wave coming for California and the rest of the Southwest starting today, maybe tomorrow. And it's going to be horrendous, caused by marine heat waves and global heating. So since this is going to be in the news, people, since this is what's making the headlines and making your weather almost unbearable, let's talk about it. A little bit of business first. My book, it was 100 Days and End of Civilization novel. It doesn't go into a lot of this stuff, although it's global heating plays a particular role in the plot of the book and what these people have to deal with. The end of civilization, which, I mean, maybe we're on our way there, lots of people think so, will make it more difficult to deal with global heating. I could talk about that too today, but I'm not going to. It's another topic. It will kind of come up today, so just keep that in mind, that the end of civilization will make it much more difficult to deal and cope with global heating. So if you're coping now and you don't really care, that's fine. Maybe you don't have to care. But in coming years, if we don't have all the things then that we have now to help us cope, if we don't have all the things then that we have now that help us cope now, then coping in the future is going to be difficult to impossible. And that's just how it goes. And these transitions from, well, I'm coping, I don't really see the problem, to a different situation where, oh, now I'm not coping at all, and all of a sudden this is a massive problem and I'm not sure I'm going to survive. That transition can happen in a few days. And that's what this book is about. 100 days of that. Link is in the description, available on Amazon. You can get an ebook, a paperback, or a hardback. And if you get the book, which I recommend, when you're done reading it, pass it to a friend. Do them a favor and help them to get clued in, because this is what's happening, folks. We're going to talk about marine and or ocean heat waves. I may actually flip between the words, because everyone has their habits. Marine heat waves. Marine means ocean. This is a picture. If you're just listening, I'll try and describe what we're looking at here, but you probably do need to have a browser open so that you can watch the video. So what do we have here? We have, this is earth.nullschool.net, which I refer to a lot. And this is, what's it called? Equirectangular. I have to get over here so I can hover over this. Equirectangular, yeah. This is a map of the world where you kind of unroll it so that you see all of it at once. Unfortunately, it distorts the north and south poles, because the north and south poles are actually really tiny compared to the equator. So when you unroll the north and south pole, they have to get bigger. And otherwise you can't have a cylinder. So it distorts the north and south pole. This is the projection where Greenland looks as big as the United States of America, even though it's maybe like 1/4 the size of the U.S. lower 48 states. People tease that Trump must have seen this particular projection of the Earth and noticed that Greenland was really, really huge, and that's why he wants it. Well, it isn't. This projection distorts the poles. But for our purposes, we're just looking at the oceans anyway. So the distortions don't matter. So what is this? This is the current as of, I think it was, I could check them yesterday. This is current as of yesterday, temperature anomalies on the oceans. Temperature anomalies means for any given point on here, and there's billions of points on here, for any given point on the Earth, if you looked at the long-term average temperature and then you looked at today's temperature in comparison to the average, would today's temperature be abnormally warm or abnormally cold or pretty much average? So you have to have an average, and then you compare today to the average. And if it's hotter than it should be, then that's anomalously hot. And if it's colder than it should be, that's anomalously cold. So this is not a map of temperatures. This is a map of anomalies, because that's what we're interested in if we're going to talk about marine heat waves. A heat wave means it's hotter than it should be, right? If you have a heat wave on land, you're saying, "Ooh, it's been really hot this week. What's going on here?" And so a marine heat wave is exactly the same phenomenon. It's not that it's a hot water or cold water. It's that it is hotter than it should be. That's a heat wave. So this is showing the marine heat waves over the entire planet for the water. This is not showing land, only the water. Now, if I go over here to another tab, I can show you the temperature anomalies for the same projection, except now this is 12 years in the past. So this is going to be March of 2014, okay? And it's different. Now this is March of 2014. There's a lot of red. That means unusually hot water. But there's also a lot of blue and purple, which means unusually cold. So compared to an average, the planet as a whole in 2014, yes, there were definitely some warm pools, but there were also some cool pools. And every place where there isn't really a color to speak of, which here would be black or slightly red or slightly blue, then those are average. There is no anomaly, so there's no color. It's black. But when you go forward 12 years, this is the picture. It's mostly reds and orange and yellows, a lot of yellows, which is intensely above average, and also very little of the blue and purple. So this has been going on for the entire 12 years. There was a marine heat wave in the years between 2015 and 2016, which is why I chose to go back to 2014 in this tab, because I wanted something closer to normal. If I picked 2015-16, that's another year of marine heat waves. But to be honest, everything since about 2017 or so has been increasingly hot. And we had a major jump in temperatures about 2023 that has not returned. It didn't fall back much. And that really threw people for a loop. That caught the climate science community by surprise, which is not a good thing. That means that we were not expecting that. That means we had no signal from nature in the years prior that 2023 would be extremely variant, way off the charts. And it continued into 2025 and now 2026. We are basically off the charts. We're nowhere near average. And we're so far out of average that it's not even really worth discussing average anymore. And this map shows that there's very little of the ocean that is cooler than it should be. Almost nothing, really, almost nothing. And there's very few places that are just average at best. Everything is pretty much in the red, the orange, and the yellow. And there's a lot of yellow. If I go back to 2014, there's not much yellow. So there are places that are out of alignment with regards to the average up to 2014, but they're not hugely out of alignment. If we go to 2026, yeah, that's kind of really common now. This is a marine heat wave. It takes a long time to heat the water. There are some exceptions to that, like the presence or absence of hot water in the equatorial Pacific Ocean, which I'll talk about in more detail probably a little bit. That's the ENSO. The ENSO can change over the course of 6 months or a year, 6 or 12 months. It can go from a cold phase to a warm phase, and that's well understood. I think there's a couple of more. I can't really name them, but again, this isn't my wheelhouse. I'm not really an oceanographer, but the ENSO gets a lot of discussion both in meteorology, which you might run into on your evening news, and also in the climate space. We talk about the ENSO a lot. The South Pacific, equatorial Pacific, if you rather, is huge. It's absolutely enormous. In fact, let me just switch this from temperature anomalies to actual temperatures, and it's a little easier to see. The Pacific Ocean, I'll grab my drawing tool. The Pacific Ocean, and we'll just end this at like Malaysia, just to have a place to stop. If you call this the Pacific Ocean, equatorial Pacific, this is like 3 or 4 times bigger than the equatorial Atlantic. And I think you could even make a case without too much difficulty that the equatorial Pacific even includes the Indian Ocean, because there's just some islands in between the Indian Ocean and the equatorial Pacific. So this is really the part that we're talking about compared to the Atlantic. This stretch of water from the Central America through the Southeast Asian islands in all the way to Africa, or all the way to the coast of Africa. This body of water contains enormous amounts of heat. Absolutely gobsmackingly huge amounts of heat. Water contains a lot of heat when it's hot. And once it gets hot, it takes a long time to cool it down. The cooling that we see between the El Nino and the La Nina phase isn't even because of heating and cooling. It's because masses of hot water are sloshing around like water in a bathtub. They're not heating and cooling. They're actually moving. And you can move water a lot faster than you can heat it or cool it. And that's the key thing here. The heat doesn't go away or doesn't come back. It just moves. It moves over here. It moves over there. And we're entering... I'll have to go back to this view. I'll get rid of this tool and I'll go back to sea surface temperature anomalies. We are entering an El Nino. The El Nino is a big part of the heat wave. So there's heat over here, and there's a lot of heat over here, and then there's some cold in between. I'll just outline this right here. This is the cold. This is the cold that's not cold. It's just average. It doesn't have a color. It's like black, maybe just a tiny bit of blue. It's basically just average. Not cool as such, just average. And it's being invaded by hot water from both the west and the east in this case. And this is one of the reasons why they're worried that this El Nino that's coming up, midsummer, I think, July possibly, midsummer in the northern hemisphere, July, is going to be a really bad one. In fact, I did a Google search on, the question was, how often does an El Nino event form from both west and east, which is kind of what we're seeing now. And they provided some decent definitions here. So I'm going to share these with you because trust me on this, folks. Trust me on this. From now until probably this time in 2027. So for the next 12 months, you're going to be hearing about ENSO and El Nino almost every day, because everyone's going to be scrambling around trying to explain why it's so goddamn hot. And they're going to want to blame it on El Nino. And there is some validity to that. So I want to say right now, there is some validity to that. But that doesn't detract from this. Okay, this is happening. This is a thing. Marine heat waves are a thing. Here's how it was in 2014. All right. Now you say, oh, there's some hot water there. Yeah, there is. Because even 2014 was well into global heating, folks. 2014 is like day before yesterday in this whole scheme. It wasn't that long ago, 2014. We've been experiencing a lot of global heating really since like the year 2000. And this data set that I'm using to visualize marine heat waves doesn't even go back that far. 2014 is almost the beginning of the data set. If I could go back further, I would, but I can't. So I'm picking data for normal, quote unquote, it's actually well into global heating. So what you're seeing here in 2014, March of 2014, I'm saying, well, this is an example of not a marine heat wave. Actually, this is not. This is an example of early marine heat wave. We were already having the onset of marine heat waves because we were definitely well into global heating. Now, I can't prove that. I don't have data for that, but everybody knows this is true. planet's been getting hot for a long time. This view is March of 2014. I'm going to go back to the present, and you can see the transition here. It's pretty crazy. So back to El Nino. Again, you're going to be hearing a lot about El Nino. Everyone's going to say, oh, it's all caused by the El Nino. When the El Nino is gone, all the heat's going to go away. Not correct. They have to say that. It's not correct. The marine heat wave never goes away. Ever. There's nowhere for it to go, folks. There's nowhere for the heat to go. It's in the water and it stays there. And the only conceivable place it could go is back into the air where it came from. If the air comes over the water and the air is a little bit cooler than the water, then the water can transfer heat to the air. Well, then what happens? Well, now the air is warmer than maybe it should have been. So the heat that's stored in the water is now part of the Earth system forever, essentially. And at some point, you won't be able to have cool days anymore because there'll be so much heat in the water that unless you live really close to the North Pole or the South Pole, you're going to be affected by marine heat waves. But I'm going to show you something about the South Pole real quick here that's going to turn your hair white, what's going on down there. So here in my definition, types of El Nino formation. El Nino formation. You're going to hear a lot about El Nino. Let's talk about El Nino. There's a Eastern Pacific El Nino and a Central Pacific El Nino. The El Nino temperature, meaning the index that they decide if it's an El Nino or La Nina or halfway in between, is determined kind of in the Central Pacific. Not on the east, not on the west, but in the Central Pacific. So there's an Eastern Pacific El Nino. That means the hot water forms in the eastern side closer to Central America. Remember, we're talking about the Pacific Basin here. And then it flows west. And then there's a central formation that forms more in the center and just kind of stays there, where they're actually measuring the temperature. It's an important region. I was hearing recently that there's a third way that water sloshes back and forth, like in a bathtub. And it's where the hot water that's in the west, so over near the Philippines, New Guinea, Indonesia, that water actually sinks and travels under the surface. And it shows up in the Eastern Pacific, near Central America. And then from there, it flows out across. And these are called Kelvin waves. I'd never heard of this before. Again, this is not my wheelhouse. I'm learning. I'm trying to learn. And when I learn something, I try to pass it on to you. Because this stuff is really complicated. And people are going to try to simplify it for you. And that's not a bad thing. But as this starts to bind, as this starts to roll over us, I think the simplification, which is well intended, is ill-served. Okay? It's not what we need. We kind of need to understand what's happening to us. So these Kelvin waves, which are subsurface, so they're below the surface of the ocean. If you were in a boat, you'd be on the surface of the ocean, going back and forth. Below your boat, down deeper, not real deep, but a little bit, enough so that it's not on the surface, the water sloshes back and forth across the equatorial water, and it comes up in the east. And when that happens, when you're getting both intrusions of hot water from the east and a Kelvin wave sloshing from the west back to the east, then this is called a both sides event. And I heard that just recently, which I'd never heard of before. And so I had to investigate it. And that's why we're having this conversation right now. I learned something and I'm sharing it with you. The coming El Nino is going to be a both sides event. The reason why that's important is because I think, and I think they say here in this same definition, that global heating is going to interfere with the ENSO formations so that we don't just get an east side event and a central event. We will start to get more both sides events, both sides. So these El Ninos coming up in the future, well, certainly the one this summer, is already going to be an intense El Nino, a both sides El Nino. But even in future years, these are supposed to be rare events, by the way. It's supposed to be normally an east side formation, and normally a central formation, and very rarely, like every 20 years or so, you get a both sides formation. Well, they're projecting now that because of global heating, both sides formations are going to become more common. And the both sides formations, not just east, not just central, both sides, lead to enormous El Ninos. And this is important because an enormous El Nino contributes to the perception of ocean heat wave events. And the both sides and the intense El Ninos also change weather patterns. And that's a big deal. That's a big deal. That's a huge deal. Let's see, where was I? I was here. Okay, so let's scroll down. Let's look at both sides or extreme events, which we're getting this summer. Okay, that's why we're reading this, because an extreme event is coming this summer. Pay attention, people. I'm not making this shit up. While most events favor one region, again, east side or central, the strongest El Nino events on record, such as 82, 97, and 2015, are so intense that they involve extreme warming across both central and eastern Pacific. Extreme warming, a major ocean heat wave event. Frequency. Historically, these catastrophic basin-wide events have occurred roughly every 20 years, so almost generational time. You wouldn't expect to see more than 2 of these in your entire lifetime. Future projections. Climate models suggest that as global temperatures rise, global heating, the frequency of these extreme whole basin events could double, potentially occurring once every 10 years by the mid-21st century, so by 2050. The models are always sandbagging. They always take kind of an optimistic cut on the data. Why do they do that? I could be conspiratorial. I would have reasons to come up with that. Maybe it's just conservative science. Maybe it's just not wanting to be wrong and always picking something that will probably almost certainly absolutely be correct, and then you don't have to worry about someone coming along later and saying, hey, you were being alarmist. If anything, you want nature to overshoot what you're projecting so that someone can't say you were alarmist, or that you had an agenda, or that you had a conspiracy, or whatever, okay? So they sandbag to be on the low end. They would rather be exceeded and come back and say, well, we knew it was going to be at least as bad as we projected. And then if you want to complain, you could say, well, you didn't warn us enough because it was way beyond that. And they can always say, well, that's your business. Take it seriously or not. We gave you some data that we were confident in. So when these guys say that these extreme events could double, so meaning every 10 years, they're sandbagging. Absolutely guaranteed 100%. It's always that way. Every time someone makes a projection on the climate and then something happens later to prove it correct, their prediction the reality will always come sooner than their prediction, worse than their prediction, larger than their prediction, meaning affecting more countries, more people, more land area, whatever. Okay? They're always sandbagging. And I understand the motive for doing that. But it means when we interpret their projections, we have to just keep in mind they're going to give you the rosiest possible projection. So I'm going to interpret this for you because that's my job, because I know what they're doing. So when they say double every 10 years for these full basin events, these, what do they call them? Catastrophic basin-wide events for El Nino, which again is part of the ocean heat wave. They say every 20 years. And then they're saying it could be as much as often as 10 years. Then it's going to be as often as maybe 5 or 6 years. Cut that in half. Oh, and by the way, not only will they occur more often in a heating planet, they'll be more intense. So the temperatures will swing wider. There's even some question that the El Nino phase, which is the cool phase, might even be hot. The El Nino phase will be hot, but it won't be as hot as the hottest, most catastrophic basin-wide events that we call El Nino. So they'll still be relatively hotter and cooler, but even the coolest La Nina swing, the cool swing, will be as hot or hotter than previous El Ninos. See, the whole thing is on the move. The entire window of what's maximum and minimum is actually, the window is on the move. The coldest phase in the future will be about the same as the warmest phase was in the past. And this does not get discussed. Scientists won't point this out. It's called moving baselines. They'll just simply say, this year compared to a year 10 years ago is about the same as it was 10 years prior to that. But what's happening is the baseline is moving. And that's actually a strategy to not be alarmist. You just let the baseline keep moving. That's why when I pointed out that, yes, here we have a lot of reds and orange and yellows, and over here we don't have quite as much, but this is 2014. This data was well into the era of global heat waves. Well into. We just don't have data for older than this. So already we're skewed. Already, even in this exact discussion, using this scientific data, we're already skewed towards hotter. Even the cold 2014 is hotter than would have been in previous decades because of global heating. And yet it doesn't really compare to this. This is 2026. This is the current marine heat wave. And this is absolute ruin, people. This is ruin. This is ruin. At some point, this is simply the end of the world. I'll say the dumb thing. I'll say the dumb thing because it's what people say all the time. So I'm going to say it too. And then I'm going to be savage about it. If this continues, we will see massive changes to the ocean that will affect sea life and land situations as well. For example, we'll have coral bleaching events if this continues. We'll have massive loss of sea life all over the oceans if this continues. Fisheries will collapse. Estuary will collapse. And then, if this continues, we'll have massive torrential rains in coastal areas. And we'll have massive hurricanes and typhoons and cyclones spinning up in these hot waters, because these are the hot waters that fuel these storms. If this continues, okay, that's what people will tell you. If this continues, it's going to be terrible. Okay, this is going to continue. There's nothing else for this to do. This is physics. There's no if this continues. As this continues, when this gets worse, as this gets worse, that's how you talk about this, because that's how you have to talk about this, because that's physics talk. We're talking physics now, people. We've jumped out of an airplane without a parachute. Gravity wins. There's no if I hit the ground. When I hit the ground. When we hit the ground. When the ground hits us, then we can talk about what's going to happen. Because it's going to happen when it does. Not if it does. When it does. And this is physics too. This is physics. As the oceans heat, marine heat waves will get worse. Everything associated with marine heat waves will continue and worsen. Everything. Forever. And this does not go back. This cannot go back because physics doesn't rewind. Physics goes, and it goes where it's going. And this can never, ever be this unless someone just draws it that way. You could go to 2026 and pick your baseline for what you consider average, and 2026 could look just like this. 2014. But if you don't do that, if you just do the honest thing, then 2026 looks like this. But even 2014 is based on a period of global heating. We just don't have data for this picture that goes back far enough to not have global heating. This is already global heating. And so comparing this to this is simply comparing the same ocean configuration under a middling global heating or marine heat wave onset to current day, where marine heat waves are the rule rather than the exception. There's another way I can show this. Is this it? No, this is sea ice extent. Let's do sea surface temperatures. Okay, this is global sea surface temperatures with the understanding that the northern hemisphere and the southern hemisphere are generally directly out of phase because their summers and winters are opposites, but you can normalize the data for that. So here we are, global marine surface temperature. Over here on the right, and I'll hover over these numbers, these are each year. And from left to right, on the bottom of this chart, you'll see that it starts with January on the left and December on the right. So when you hover over a year, let's hover over 2014, because that was our other chart, right? Let's hover over 2014. January of 2014 is on the left. This is gray line. And December of 2014 is on the right, so the end of the year. And 2014, this proves my point from earlier. 2014 is above average. What is average? The average, again, you have to be watching this on YouTube, not listening, but I'll try and make sense out of this for people that are just listening. The average from 1991 to the year 2020 is this heavy black line, and 1982 to 2010, a different bracket, okay? 1982 versus 1991 to 2020, 1982 to 2010. So overlapping but different. You'll notice that the 1982, the earlier bracket, is lower than the newer bracket. Now these are both averages, but they're averaged over different time periods. But the time period that's earlier, 1982 to 2010, is lower than the average from 1991 to 2020. See, this is moving baselines. And you could just keep doing this. It proves that the baseline, what we call average, is actually increasing. You have to be careful what you call average. So when I go back to this other chart and I'm looking at 2014, again, 2014 is already above average. You just saw the data. It's already above average by a lot. So all these reds and yellows and oranges, these are marine heat waves in their own right, but 12 years ago. And this chart is 12 years later. It's a trend, and the trend goes back to this chart. Now, I actually have additional years of data. I can go back here, 1981. Let's get 1982. It's a full year. So this is the daily sea surface temperatures for the world. So we're averaging it across lots of data points for the year 1982, from January on the left through December. This heavy gray line is at the bottom of all these lines. All these lines. How many lines are on here? 40 of them? Okay, it's the bottom. And if I do 1981, it's even below that. But 1981 is not a complete year. It started in September 1st. So 1982 is our first complete year. It's at the bottom of all the years. And if I just go up and down between the years 1985, why is there no data for 1985? Interesting. You'll see all these years, all four of these years, 81, 82, 83, 84, at the bottom of the pile. So the temperatures for the world in the oceans, so this is daily sea surface temperature, was nowhere near what we now call the average. It was below average. But where is the average? How are you calculating the average? This is really critical in mathematics. What are you going to call average? We could actually call the year 1983 average. We could do that. But clearly it's not, because it's at the bottom of the chart. It should be in the middle of the chart if it's going to be average, but it's at the bottom of the chart. And the key here is that we have been in ocean, this is sea surface temperature, okay? We have been in marine heating since all the way back in the 1980s. Not 2014. All the way back in the 1980s it started. Let me go to another set of years. So this is 86, 87, 88, 89. You see, it's all at the bottom of the stack. 91, 92, 93, 94, 95, 6, 7. Okay, now it jumps up. Finally, 1997, it jumps up into what we're now calling average. Well, that was a hot year. 97 and 98 winter. The 97-98 year is considered hot. The El Nino was really bad in that period of time. Then we go back to 98, it drops back down. Because 97-98 was a record El Nino, a both sides event. 98, 99 goes back down, 2000, 2001. Now 2001 has increased to about what 97-98 is. But this time it's not going to go down. It doesn't go down anymore. Because this is not caused by El Nino. This is caused by global heating. Global heating has kicked in. Yes, we go back to 97, 98. There was a significant El Nino, and for 97, 98, it was up in, it was significantly increased, and then it dropped back down. But by the time you get to 2001, there's no dropping back down again because of global heating. It's getting hot, and the heat is being transferred to the oceans. So this has increased. 2004, 5, 6, 7. 6 was a lot. And I think 5 and 6, 2005 and 2006 was the next El Nino event. Let's maximalist El Nino. Let's check here. 97, 98. Okay, 2015 we had a maximal El Nino. So let's just look for that one. 2003, 2004, 5, 6, 7, 8, 9, 10. Now you can see it's significantly above average, right? And it kind of just stays above average after a while. 2015 and 16, which was a maximalist El Nino event, we just read that, drops back down a little bit in 2018, 19, 20, 23, 2021. Now this is starting to get at the top of the chart for all the previous data. 2021, 2022 is at the top of the chart. Something happened in 2023. I'll tell you that right now. Something happened in 2023 that made all the climate scientists sit up and take notice. I have heard various explanations for why it happened, but we know what happened. The temperature of the planet jumped. These are the sea surface temperatures, and in the latter half of 2023 is literally off the chart. They had to redraw the chart to make this fit. 2024 was also off the chart. 2025 was maybe a little bit back into the normal, and 2026 is following 2025 and it's probably going to go off the charts. So since 2023, something has happened. All this data is off the chart. We go back to 2022, 1, 2020, 2019, 18, 17, 16. This is all high, but it's still within the earlier years. There's no outliers here. 2021, 21, 22, and then 23. Boom, there you go. 2023 it happened. Let me grab my drawing tool. I wish that these would stay lit. I guess there's no way to do that. There's another chart where I can do this. So I can't really use my drawing tool because if I do, I'll lose my line. So, but just imagine early month of 2023, like January, February, were within the other data sets. And then about March, April, May, it left the prior data behind. And then, see, some of these stay lit. So why? 2025 stayed lit. How'd that happen? Yeah, you're supposed to be able to click on it. It's weird. I guess the color is, it does stay on. What it is that the color is different. Can I change the color? Can I change the color? Is there some way to change the color? No, I can't change the color. It's just all gray is the problem. So we're just going to have to live with that. 2025 was hot. It was certainly more than 2023. No, it wasn't. I'm sorry. It was actually a little bit less. 2023 was crazy, people, just so you know. And 2025 was at least higher than all the other data. You can see that in the chart. And 2026 is trending towards what 2023 did. So we're already hot. We're going into a hot phase, and then we're expecting a maximalist El Nino event, a both sides, full basin El Nino event, middle of the summer. So, wow, this is going to be, well, can I call it interesting? Can I say this is going to be interesting? It's going to be interesting. I mean, seriously, it's going to be interesting. And please notice, all these lines since about 2008 have left the average behind, seriously behind. And now when you get to 2023, 2025, and 2026, the average is in the dust. We're way outside the average. We're off the chart at this point. And that's multi-years of reality. I mean, the whole chart is reality. Do I have to go back? I'll go back. Let's look at some of the early data. It's way down here on the bottom of all these data sets. It's way on the bottom, okay? and go up to the next set of data, 87, 88, 89, still way off the bottom of the chart, way on the bottom. If this was all you saw, you'd think, well, there's nothing really important going on. And then 97, 98, it jumps up. And after that, it jumps up and it stays up. 2003, 2004, 2005, 2006, 7. It starts to climb. And then about 2010 or 11 or so, we're off the chart. 2015, 16, we're off the chart, and we stay off the chart until 2023, where we jump again. And it's kind of doing that. It's kind of going in phases. There's a low phase in the early 80s, mid 80s. There's a transition phase where they're all kind of clumped together. And then in about 2023, we go into a third phase where it's way off the chart. And this is all sea surface temperature. The ocean doesn't change heat content quickly. And this kind of jumping behavior blows people away. It's really hard to explain, honestly. The physics just doesn't align. It takes a lot of heat to heat water. There's a lot of water on the Earth. The water mixes. And how can you suddenly get a jump in 2023 that really never comes down? So it's clearly anomalous. It's clearly off the chart from 2023 forward. And I have heard various explanations for why that is. But I haven't heard a definitive explanation. I've just heard different theories, not even theories, hypotheses about why it did that. But so far, maybe I'm wrong, but I don't think there's a diagnosis. What is this? What happened in 2023 that this really did leave the average in the dust? What happened? And even the average has been increasing. So the average from 82 to 2010 is lower than the average from 91 to 2020. So that tells you right there something is happening. It's just that 2023 just leaves it behind. Dusts it. It's in the dust. And what happens from here? I don't know. This summer we're supposed to get a significant, some people are calling it Godzilla. We're getting a Godzilla El Nino in midsummer into probably 27. And I guess we'll learn something, won't we? I guess we're going to figure it out. We're going to discover what all that means as all that happens. I don't think there's anything more to say about El Nino. Again, you're going to hear a lot about it. You're going to hear about it constantly because everyone is going to try to explain what's happening. It's going to get hot. It's going to get fucking hot. There's more I can show you. Let's do this. Let's do this, shall we? I am going to switch from temperature, ocean temperatures to wind. Yeah, here we go. Here we go. I'll keep this projection. It kind of works. This, in the northern part, let me get my drawing tool. This is the equator right here, straight across. These lines you see weaving, these purple and red lines you see, this is the jet stream, the northern jet stream. The northern jet stream has very strange behavior in about the last 15 years or so. It's got this waviness that goes on. And this is, there's a lot of it. It just does this now. And sometimes it just disappears. You can't even tell where it's going. But it's got these wavy behaviors. This is because of a collapse of the polar vortex, which is known to cause these meanders in the jet stream. But the key to this is that these meanders, here's a significant one that came down here. I'll mention this one in particular. Here's the Hawaiian Islands right here. I just circled. The Hawaiian Islands just had a massive storm event caused by these meanders in the jet stream. So in other words, the massive storm event that just took place in Hawaii is due to a collapse of the Earth dynamic system. And what happened was, I'll clear this for a moment. What happened was that there was I can go back in time, actually. I just go back in time. Let me go back in time here. Where's Hawaii? There it is. This is the 15th. What is today? The 16th. I'll go back a little more. This is the 14th. This is the 14th of March. I went back a little ways. I'll grab my drawing tool. There is a massive twist in the jet stream that came down like this. And this created a horrendous storm off of Hawaii. They call it a Kona low. It's nothing. We need new names for these things because this is a breakdown of the Earth system. This isn't a Kona low, whatever that was 40 years ago. This is something else. You can call it a Kona low if you want to, but it's something else. And what it did was these things, these loops, they turn. I'll put some arrows on here. They turn anti-clockwise, okay? They rotate. And so as it's rotating anti-clockwise, it draws moist, hot air from the equatorial Pacific. Now, Hawaii is already partially equatorial. Wife needs something. She's going to be banging around. And it aimed this moist air right at Hawaii. Again, here's Hawaii right here, this little dot. It's tiny, you can hardly see it on the map. It aimed this moisture right at Hawaii, and you can kind of see how it did that. This gearing just grabbed that moisture and slammed it in Hawaii. But the key to this event was that the center of this was cold. This is a cold core cyclone. A cyclone is a rotating wind, and this is a cold core cyclone. The other cyclones you're probably familiar with would originate in the equatorial regions, like off of the west coast of Africa or off of Central America, and they would form over hot water. Hurricanes, right? Caribbean hurricanes, typhoons in the South Pacific that can hit the Philippines and Japan and Thailand and sometimes Australia, except they're called cyclones. Cyclones in the southern hemisphere, hurricanes in the Atlantic basin, and typhoons in the Pacific basin, but they're all the same thing. They're warm core cyclones. They form over warm water. But this cyclone that hit Hawaii is a cold core cyclone. So this is what happens. And this is what has been happening in the U.S. for months now, in this continental U.S. Hawaii is also the U.S. In the continental U.S., the 48 states, we've been getting cold core cyclones coming down from Canada and dumping torrential amounts of precipitation. Precipitation is a word that includes rain, hail, snow, ice. And you say, no, those can't all be the same thing. Yes, they're all precipitation. And this cold core cyclone, because it's cold, it could take that warm, moist air that was being dragged up from the warm pool of water at the equator. Let me go back to this thing, and I'm going to make this current, and I'm going to set this to ocean sea surface temperatures. So again, we're on another chart now, but I have to do this comparison. Here is Hawaii, and right down here, there's a massive pool of hot water. This is all current. This is now. This is not future or past. This is right now, 2026, March 2026. The winds under the influence of this cold core cyclone picked up the hot, moist air that was above this hot water. See, hot water evaporates, and it transfers heat to the atmosphere too. So when you have really hot water, you get warm, moist air above it. And when this cold core cyclone off of Hawaii picked up that warm, moist air, the cold nature of the cyclone was like wringing a rag. That's what happens when cold air meets warm, moist air. It just wrings out the water in the warm, moist air, wrings it out like squeezing a rag. So the jury is still out on what the damage is to the Hawaiian Islands. Lots of places had 30 to 40 inches of rain over the course of a few days. The event is not done yet. This massive cold core cyclone is moving on. This was a few days in the past. I'll set it to now. It's kind of moving on, but not really. And they're expecting more torrential rain events in a few days. So over the course of this entire event, if you allow the two events to bracket each other, they're already close to 4 feet of rain in parts of the Hawaiian Islands, up to 40 inches in some places, so it's almost 4 feet. And they're expecting up to 8 feet of rain over the course of this this 1 week period. And that's a lot of rain. I don't care who you are. That's a lot of rain. I didn't mean to do that. There we go. I want them the same size. Okay, good. Now, at the same time that, okay, let's clear this. Why does it do that? It jumps around. I hate it when it does that. I want them to be the same size. Okay, they're the same size. At the same time that, I guess this really is the chart I want. At the same time that Hawaii was having a cold core cyclone formed by this dip in the jet stream, this continues. Okay, you can see what it's doing here. This is a long string of anomalies in the jet stream. Over here, though, we're getting hot air. This cold air was pulled down from the Arctic by this dip in the jet stream, and this hot air is pulled up from the equator. Now, this what's right under this H is the state of California. So while Hawaii right now is having a cold core cyclone that's dropping 4 feet of rain in places on the islands, up on the mountains, the peaks, but doesn't matter. It's still the island. And all that water has to run back to the sea. So you get massive flooding. And that's been their biggest infrastructure problem, is the amount of rain they've got is just tearing out bridges, tearing out roads and culverts, landslides, and it's going to take weeks to clean it up and to, of course, repair things. There were big electrical outages as power poles were knocked over by the landslides and by the rain. There were also really high winds. So this cold core cyclone was, in many ways, very much like a hurricane, but it wasn't, because it wasn't a hurricane. It didn't come from the south. It didn't form over warm water. It's a extension of the jet stream, which is falling apart due to global heating. The jet stream is falling apart, and so when this loop dumped down, it was able to spin air and create, just like any cyclone, to create high winds, just like a hurricane can. This is a cold core cyclone, so it's not a hurricane, but for different reasons than what a hurricane uses. A hurricane's a heat engine. This is not a heat engine. A hurricane is a heat engine, and it forms over heat, and all the spin in a hurricane or a typhoon comes from the heat, you see. It's a heat engine. This is not a heat engine, because it's formed over cold water. So it's not a heat engine. Is it a cold engine? No, it's not a cold engine either, because cold doesn't provide energy to be an engine. It's not a cold engine. It's a breakdown of the jet stream and the rotational energy of the cyclone that Hawaii had to deal with comes from the jet stream, which is a 200-300 mile an hour wind at altitude. But when you get down to the surface, it still has high winds. And so when you get a breakdown of the jet stream and a big piece of it breaks off and it comes south and it's still spinning, even with a cold core, it's still spinning, then you get spin. It's not a hurricane. You can't call it that. It's something else. Now we're going to have to start naming these things. Well, Michael Snyder called it a Kona low. I think he spent a lot of time in Hawaii, so he's familiar with the terminology for Hawaii, what they call these things, a Kona low. And the implications were that, Kona lows are really rare. Not anymore, they're not, because the jet stream is broken, folks. It's busted. And if you've been on my channel and you've heard me complaining about these things, you'll know I say this all the time. The jet stream is busted. It's not normal. And it's never going to be normal. Ever. Not in the history of ever, forever. It can't, because global heating never stops. Global heating only gets worse. And what is breaking now is going to break 10 years from now. Except worse. I mentioned heat. There is heat coming for California. Oh my God, what are they saying? All right, let's do this. Let's leave daily surface air temperatures. No, that's not what I want. I want now I'm lost. What do I want? I'll go back here. Outlook forecast maps. Is this it? Daily surface air temperature. That's not what I want. How do I get this? No. I'm sorry. I can't see. Okay, this is the one. Outlooks. Yeah, because it's over multi-day periods. I'm sorry for that. I don't use this tool enough to be that familiar with it. So again, these are monthly outlooks. So it's they'll give you 1 to 3 days, 4 to 6 days, and 7 to 10 days. It's the outlook, right? They're forecasting now over blocks of time. Now this current view, initial view, is the Arctic, and I'm not really interested in that. Oh, there's some crazy stuff going on in the Arctic, but let's skip that. Let's go to the United States. That's where I live, so I'm a chauvinist. Sue me. Well, we can look at Europe. Oh yeah, we're definitely going to look at Europe, but let's look at the United States right now. So what are we seeing here? The left-hand map is the temperatures, average temperatures for a 3-day period beginning today through the next 2 days, a 3-day period for the United States. The the left-hand map, and I can click on this. This left-hand map shows actual temperatures, expected temperatures, and what is it? 0 degrees Fahrenheit is dark blue. So you don't even get to 0 degrees until you're almost off the top of the map. The rest of the United States is warm. So there's a lot of 40 degrees Fahrenheit. That's not that warm, right? But it's warmer than 0. And down here in California, the Southwest, we're getting into 80 degrees. Yeah, about what you'd expect. Actually, that's hot for March. But okay, fine. We'll live with it because we don't know any better. If I go back to showing my two charts, this chart on the right is the anomaly. So is the temperature in California shown on the left average or above average or below average? Well, that's where you have to have the anomaly. So this map on the right is the temperature anomaly, the 2 meter temperature anomaly. 2 meter means about head height to me. That's where they measure it. They don't measure it right on the ground. They don't measure 100 feet up in the sky. They measure it just about the height of a climate scientist. Okay, so they can read the instruments or something. Just about the height of a climate scientist. So the 2 meter temperature. The anomalies are here on the right. These are anomalies, and you can see the numbers. There's positive numbers and negative numbers. So in the Midwest, we're looking at negative numbers. So this is below average. And in truth, in faith, there have been some crazy below average numbers in the central and eastern United States. Despite that, the lower 48 states, taken as a whole, have just exited their warmest winter on record. Even with numbers like this, minus 16, minus 14, meaning 14 degrees below normal. Even with numbers like this, the winter we just left behind in the Northern Hemisphere is the warmest on record for the lowest 48. We had the warmest Christmas on record lowest. We had the hottest Christmas on record in many parts of the U.S. in 2025. Hottest Christmas on record. And most of the states, lower 48, just exited the hottest winter on record. Now, nobody will tell you that. Nobody knows that. Nobody works with that kind of data. Nobody checks the temperature every day over the entire 48 states and calculates what the average is and calculates what today is compared to that and makes an assessment. Nobody does that. Your meteorologist doesn't do that for you. They'll never mention this because you don't care. Most people care, well, do I need an umbrella tomorrow, or should I wear a coat, or should I wear shorts when I go out, when I go to work? Should I wear a dress or pants and I bring a coat and an umbrella, or can I just go and wear a short dress? And these are the kinds of questions that people ask regarding the weather, and that's all they care about. They don't care that the winter just exited was the warmest on record. But it was. So there you go. Right now, today, we're entering an enormous heat wave in the West. It's going to be amazing. I mean, bad, but still amazing for people who track weather. The heat wave we're about to hit is going to break all records everywhere for everything for all time. Hot. We're going to have temperatures in the West, California, Nevada, Arizona, Utah, we're going to have, and even up into Oregon, we're going to have temperatures in the West that will be considered high temperatures, hot days, if it were summer. And it's early spring. So this is the day 1 to 3 outlook in the U.S. I'm going to jump forward to the data 4 to 6 outlet and look what happens. 4 days from now, this is what we get. Crazy. This is crazy hot. You see some numbers here. I'm going to click on this chart to get it bigger. We're going to have 26 degrees above normal in places. We're going to have 25, 24. Half of the country, more than half, is going to have temperatures that are 20 degrees or more above normal. 20 degrees or more. So if you were expecting a 70-degree day in the spring, you're going to get a 90-degree day. And that's crazy. Now, of course, the concern is that people won't believe it. They won't believe that this is what's happening on day 4 of this event. They simply won't believe it. And so what? They'll plan their day around not believing it, and they could get caught out in a dangerous situation. It's really easy to die from the heat, folks. If you don't have water, if you don't have air conditioning, if you don't have someone to look after you, if you're an elder or a child, if parents usually leave their children in the back seat of the car because, it's never that hot. Well, during this event, which is going to be like a 5 or 6 day event, if you do that, you run a serious risk of losing your child. Previous years, you wouldn't have lost your child, leaving your child in the car in March unattended. Well, this year in March, whatever are we, 16th already? 16th, 17th, 18th, 19th, 20th of March. If this year you leave your child in the back seat of the car and go inside to get your nails done, you're going to come out and your child's going to be dead. Last year, no. This year, yes. And that's how it happens. It doesn't happen because people deliberately do something that causes harm. They are taken by surprise by something unusual that happens to them. You see the difference? Your behavior may not change. Your environment is changing. And we are going into an anomalously hot 1 week period that people simply will not believe. They won't believe it. They won't believe it. It'll be forecast. The warnings will be posted. The sirens will go off. They won't believe it. It happens all the time. Leaving this, we can go back to this chart. That was the 4 to 6 day outlook. Looking at the 7 to 10 day outlook, it starts to cool off again. But this is 10 days from now. This is going to be a long event. Now, global heating, that's why this event is happening. Can I go back to this chart? California is, I'm going to get a different color. California is, well, the area in question is right here. That's the area in question, including California. There's this big ridge, as they like to call it, that's dragging hot air up from the equatorial Pacific. Okay, are we all on the same page now? This big bump will slowly move from left to right. It will slowly do that, but it's going to take it 10 days. And during those 10 days, the H doesn't move very much. The hot doesn't move very much. Finally, eventually, it gives up. Sometimes, in some ways, it does move away. In another extent, it simply evaporates. But all of this is due to these big loop-de-loops in the jet stream. And these loop-de-loops in the jet stream aren't supposed to be there. They're being created by a breakdown in the Earth dynamic system. And they're being created by a collapse of the polar vortex, which I talk about all the time on here. And why would the polar vortex be collapsing right now? Global heating. Well, technically, it's sudden stratospheric warming, but warming is in the title, okay? Warming. Could call it sudden stratospheric heating if you wanted to. Global heating. The greenhouse effect. The greenhouse effect is being aggravated by carbon emissions from usins. And well, how are we doing that? We're burning fossil fuels. So this never stops. And even if we stopped, this doesn't stop. It never goes away. I mean, never. Like thousands of years, never. This never goes away. The heat content of the ocean stays there for a long time. Of course, the oceans just continue to get hotter, but it stays there. And the marine heat and the land heat wave that is going to hit us, this heat wave, I'll go back to day 4 to 6. This heat wave that's going to hit us is because this. People are going to have a hard time understanding what this is all about. That is about this. The same thing that happened in Hawaii with a dip down is now happening to California and the rest of the western states because of a dip up. And the dip down and the dip up are the same dip. Here's the dip down for Hawaii, and here's the dip up for the heat wave. They're the same thing. They're just adjacent. A dip down creates a dip up. A dip up creates a dip down. They reinforce each other. And by the way, I might as well mention, I'm going to change the projection because this whole world projection is useful, but it's also a bit misleading. I think one I want is this one. Yeah, you've seen this a lot on this channel, so I'll just revert back to this. And look what's happening over here. Over here we have, okay, this is the big dip up that's going to bring hot weather to the west coast, and you can see how that works. This dip down is bringing freezing weather and high winds to the east side of the country. Both these things are happening at the same time, and one is just the other side of the other. They're reinforcing each other. And this is going to give hot for the west coast, and this is going to give cold for the east coast. They're not different. They are in no way detached from each other. They are joined at the hip like Siamese twins. One creates the other. These are the same thing. This is a breakdown of your Earth dynamic system. This is not weather. Oh, you can call it weather. It's the Kona low. Woohoo! It's the El Nino. Woohoo! It's a what do they call it? Alberta Clipper. It's an Alberta Clipper. Woohoo! You can put names on these things. But it's bullshit. It's cope. It's just meteorologists using words that they've used 10, 20, 30 years ago to describe things that they think are the same thing, but they're not. This is a breakdown of the Earth dynamic system. And what is happening over here? Well, let's take a look. They're having yesterday, actually for like the last 4 weeks, for like the last 3 weeks or so, the following scenario has played out, cookie cutter style. Boom, 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 like 4 or 5 days apart. This cold meets with hot, moist air coming up. And this is like the Hawaiian thing. Didn't I just have this discussion with the Hawaiian thing? It's the same thing, people. It's not different. It's the same thing. Because it's the same system falling apart, creating the same conditions over and over and over, all the way around the planet. This cold air coming down from Alberta meets warm, moist air coming up from the Gulf of Mexico. And the Gulf of Mexico is like a bathtub right now, okay? And again, it's the same discussion as what happened with Hawaii. The cold core cyclone catches this warm, moist air, and it wrings the water out like wringing a rag, a wet wash rag. You twist it and you wring the water out with the cold. And this cold is wringing this water out, and it's creating massive severe weather. So there's a severe weather event taking place from here. Well, this was yesterday. I'll clear this real quick. There was a severe weather event from Texas all the way up into the Great Lakes. And today, there's another severe weather event related to the one yesterday because it's the same phenomenon moving east, taking place over here on the East Coast. And this key, and I can rewind this a little bit. Let me rewind this a couple of days. So today is the 16th. I'm going to rewind this to the 15th or the 14th. Yeah, well, that's probably too far. Because yesterday was when it happened. So there was a big dip coming down through here, and this created a huge event in this region. And if we go forward to today, I need a different tool because I don't like turning it off. If you go forward to today, there's a huge event taking place right here because of the same phenomenon. So these dips in the jet stream are what are causing these massive events. And the massive event that just took place in Hawaii, you can actually see it over here on the right, on the left. This massive dip is the same thing, folks. It's the same thing. It's even the same atmospheric phenomenon called the northern jet stream. This huge dip over here is what impacted the Hawaiian Islands, which are right here. It's the same thing. It's the same fucking thing. It's all the same. It's not weather. It's not weather anymore. You can call it weather. You can say it's rainy weather. It's extreme weather. It's going to be hot weather. It's going to be freezing weather. But it's not weather. You want to go ahead and call it that. But you're misleading yourself and you're misleading everyone else. It's not weather anymore. And it will never be weather again. We are out of the realm of weather. We are now in an era of consequences. Because we fucked up the Earth dynamic system. How do we do that? Let's do this again. I do this every time, and I'm going to do it again. I'm going to go to the top of the atmosphere, and I'm going to tilt the planet, the globe down until we're looking straight down on the North Pole. And this is the North Polar Vortex. It is looking better than it has in the past. This is not too bad. At least it's a circle. At least it's going in one direction in one place, but it has no energy now. It's basically lost all of its authority, and the resulting jet stream, which is about here, has kind of fallen apart. And when the jet stream falls apart, then you start getting all these dips. And we were just looking at these. I just drew the same line through the same things. This is the one in the eastern half of the U.S. This is the one in the western half of the U.S. This is dragging cold air down from the Arctic, and this is dragging cold air up from the equator, and we're getting a heat wave on the left half of the lower 48 states, the western half, and we're getting a cold wave and severe weather on the right half. And it's not weather. None of it is weather. It just isn't. Now, if that's going to be your framing, that the weather changes and we have different types of weather and the weather's this and this that, then you're lost. You're just lost. And I know the meteorologists are not going to help you become less lost. Frankly, I think they're afraid to. There has been so much misinformation about global heating and climate change that at this point it's just a third rail. If you in your professional life ever, even tangentially, like on accident, talking with your buddies down at the bar over a beer, if you ever touch climate change as a professional meteorologist, you're probably dead. They'll just kill you. You'll get so much hate mail. You'll get so much everything. You're woke and you have an agenda and you shouldn't have this job. You're no longer a professional. You just lose your life, lose everything, lose your house, lose your marriage, lose your car, everything, because you'll lose your job and you'll never work in that field again. You'll never have a job, and they just don't say it. That's a good call. I'm not going to require them to say anything about this. They're going to tell you the weather tomorrow. And maybe the day after, are in for a big heat wave on the West Coast, and they won't tell you about the severe weather on the East Coast. Or if they're on the East Coast, they'll say, we've got some severe weather, or it's going to be really cold in places. You could even have snow, winter like snow in spring. But it's just weather, and they won't tell you anything about what's happening on the West Coast. And least of all will they tell you that, we're having weather, and it's going to be nasty, and it's just like the situation in Hawaii where they're having nasty extreme weather too. They're not going to tell you that. They're not going to tell you that. Even though it's all the same thing. It's all tied together like beads on a string. The Earth system has gone off the rails. And what happens when a train gets jacked up on the tracks? What happens when it hits something on the tracks? One car goes left, one car goes right, one car goes left, one car goes right, and they're all off the rails. And some are on the left side of the rails, and some are on the right side of the rails, and they're all twisted up like a broken snake all the way down. That's what this is. That's what this is. Okay? This is off the rails. And sometimes it jumps down, and sometimes it jumps up, and sometimes it drags down a cold area to interfere with your weather, or sometimes it drags up a hot area of air to mess with your weather. And it doesn't even matter what time of the year it is. And that's why we've had the warmest winter on record, just exited. Because it's all jacked up. And it's important to know that this is the Earth system jacked up. Like a train that has left the tracks. It's jacked up, people. And it will not go forward from here. It is off the rails. It is off the rails. It cannot go forward from here, except that it goes even worse off the rails. This is the Earth system going off the rails. Everything we're seeing is symptomatic of the Earth system leaving the rails. Call it weather. That's what people do. That's what the meteorologist is going to do. My job is to tell you, that's not right. That's not true. That's not what's happening. It's not weather. Now, what can you do with that information? Good question. What can you do with that information? There's a massive heat wave coming for the West Coast. And actually, really, all the western states. All up and down the 48 states. There's a massive heat wave coming. It's going to kill people who don't believe it, who just do their usual thing, take no precautions against massive heat, and they just get caught by surprise and they die. And you can save yourself from that fate if you take it seriously. That's all I'm asking you to do, is take it seriously. You're going to hear weather predictions. You're going to hear weather predictions that sound insane. And your natural tendency will be, well, that can't be right, because that sounds insane. And when they tell you, we just exited the warmest winter in human history in the Northern Hemisphere, you'll say, that sounds insane. But it's not. It's data. It's easy to forget that we had the warmest Christmas on record in the lower 48 United States. It's easy to forget that, because that was Christmas. You were on holiday. You weren't thinking about the weather. You weren't thinking about the weather. You were thinking about Christmas. And probably on Christmas Day, people went outside and, they're thinking they should put their coat on and all this stuff. And they went outside and they didn't need a coat. And they didn't need long pants. They wore shorts and they wore a t-shirt and they drinking a beer right out of the cooler. And they're like, wow, this is weird. And then a couple of days later, they forgot about it. No one sat back and said, well, that was insane. What was up with that? Someone please explain to me. No, I'm sitting right here and I'm not moving until someone explains that to me. No one had that reaction. Nobody. I just explained to the entire fucking planet why Hawaii got deluged, 4 feet of rain. The West Coast is about to get a heat wave that's going to murder people. And right now, the East Coast has had 2 days of severe weather, to be followed by freezing rain and snow before they inherit our heat wave. Is that what actually happens? Let me see. Well, they get back to normal. In the next 7 to 10 days, they get back to normal. But they're going to feel some of this heat wave. This heat wave that's going to whack the West from California will extend all the way to Indiana on days 4 to 6. I may as well show that to you since we're kind of here. This heat wave on day 4 to 6. So again, this is a period of, it's bracketing time. That's 4 days. That's 4 days. The 4th, the 5th, the 6th. I guess it's 3 days. It sounds like it's 2 days, but it's actually 3 days. The 4th, the 5th, and the 6th. This 3-day bracket involves everything from California all the way out to here. Actually, it's all above average. I mean, it's going to go all the way to the coast. It's going to go all the way to Washington, D.C. There's no blue in here until you get up to Canada. There's some blue in Canada. And who cares about Canada? Actually, we love you, Canada. I just had no experience with Canada. Yeah, it's basically the entire lower 48 is going to go from Ermagerd, it's been so cold and snowy and rainy, to, oh no, it's really hot right now, in about 3 days. We had a lot of snow in the California Sierra Nevadas, right up here in the part of the California. We need a lot of snow in California because that's our water supply for our agriculture and our cities to have water. They had a fair amount of snow. They had like 2 or maybe 3 events that dropped a lot of snow. The rest of the time it didn't because of global heating. You can't have snow if you don't have cold temperatures. When you heat the planet, you can't have ice. Is that not obvious? When you have the warmest winter on record, you can't have ice. I mean, some places, but most places you can't. Well, right now, what little snow there is in the Sierras, and it's not even normal, it's not even approaching normal, it's all going to melt during this 4 to 6 day period. Virtually all of it. And people say, oh, that's not possible. That's fear mongering. You don't know what you're talking about. You have an agenda. No, it's just going to be so fucking hot. It's going to be 25 degrees above average. It's just going to be too hot to have snow. And that message applies to the entire planet. Eventually, this planet gets too hot to have ice anywhere. Just won't have ice. Is that a problem? Well, the U.S. Southwest gets a lot of its water from the Colorado River, which gets a lot of its water from the snow. Well, they're in a drought. It's not even a drought. It's just normal. It's just normal for the region. Normal rainfall for the region. None of which comes down as snow. Almost none of which comes down as snow. Because of global heating. Okay, you can't have snow if you don't have cold. So they don't have much snow, and they didn't get much precipitation anyway, and now the reservoirs are a dead pool. There's so little water in the reservoirs on the Colorado River that they can't even get it out. They can't get the water out. It's below the, what's the word? Penstocks. It's below the spillway. It's below the pumps. It's below everything. It's just so low in the reservoir. There's still a reservoir. There's still water in it. You can swim around in it, put a boat on it. You can't launch a boat, by the way, because the boat launch is way up here and the water's way down there. So you can launch a boat with a helicopter, but you can swim in it. You can drag your little canoe or kayak down into it. I'm probably overstating it. Maybe you can still launch a boat. I don't know. But that's a problem, okay? When the water gets so low that the boat launches up here and the water's down here and you have to throw the boat in the water, you can't launch a boat. So dead pool, that means that water's not available unless you have a bucket. That water in those reservoirs would have gone to places like Phoenix, Arizona, Las Vegas, Nevada, and the Los Angeles metropolitan area. But a dead pool is not going anywhere. Data. And it's supposed to hit dead pool June or July of this year, about the time that the Godzilla El Nino spins up and starts baking the entire planet. And of course, all the time that's going on, this shit is going on. Hot like this, heat like this causes evaporation. So whatever your reservoir was, it's going to be even less. And whatever your snowpack was, it's going to melt and then probably evaporate. The water will never go anywhere. It just goes back into the atmosphere. And this is what's happening. And of course, because it's going to be so hot for 4, 5, 6 days that the next time the wind blows up and starts blowing the air around, then someone will be barbecuing and they'll knock their barbecue over, or they'll flick a match into the bushes, and that sets off the brush, and that sets off the wildfire, and that sets off the something else, and then there's a wind, and then there's a fire, and whole cities burn up, and people will say, well, it's the firefighters' fault, and there wasn't enough water in the reservoirs, and nothing worked, and someone was woke, and someone was more concerned about budgets, and someone was in Africa, on a mercy trip, and they should have been here fighting the fire, but they were in Africa and they're woke, and it's all this other stuff, but it isn't. It's not. It's because in the middle of March there was a fucking heat wave that dried everything out, and towards the end of March someone was barbecuing in their backyard and knocked the barbecue over. The dog got rambunctious, knocked the barbecue over, and spilled the coals into the dried up vegetation and set it all on fire. and then it burned. And it burns fucking everything. And they'll blame everybody and everything else, but they won't remember that we had a 5-6 day heat wave that absolutely broke all records. Everywhere. Every record for everything was broken. Days 4 to 6. Does it matter? Does it change anybody's behavior? Does knowing that this is happening change anybody's behavior? Does knowing that this is not even weather anymore? This is a breakdown of the Earth dynamic system? Does that change anybody? Nope. No. What am I doing here? Fuck if I know. I'm done. I'm so done. But I'll be back. When will I be back? I don't know when I'll be back. When I have other things going on. Buy my book. It was 100 days. There's a heat wave. There's also a hurricane. And, the best part is there's cannibal zombies. So, buy my book. It's dramatic. And it's a user's manual on how to get your shit together before all of this goes down. Because it's going down, baby. It's going down. Oh, man. Is it going down? Here we go. Yeah, well, good luck, folks. I'll be back when I feel compelled to talk about any of this again, which will probably be tomorrow. Because, man, the next few days are going to be wild. And my recommendation to all you fine savages is find some way to not die.